having some trouble getting this one started. Okay. Hello. Welcome back, everybody, to the stream as we continue working on the operating system. I've officially changed the name, or settled on a name, if you read the title of the stream. It's one that I think is kind of cool. TwilightOS. I think it's kind of pretty. Or just Twilight. You can call it whatever you want. Doesn't really matter to me. I think it's kind of pretty. Yeah, so where are we at right now? This is where we're at right now. And we can take keyboard input. It's still doing that thing where it skips keys sometimes. I haven't figured that out yet. See how I can't seem to spell anything? I mean, I can't spell anything normally anyway. But this is definitely not helping. Let's see, the enter key works. And the line wrap automatically. Let's see, there's the bug that I tried to fix before that I couldn't quite fix. See right here how everything is starting printing on the second column. But then when I overrun the line and it wraps around to the next line, it starts on the first column. See right here how there's an F here? That's not correct. So the VGA controller code needs complete reworking because it's kind of a bodge and doesn't look very pretty. One major thing that I've done is moved everything over to C++ files now instead of just C files. So before, everything was all done in a C file, or individual C files, and C's hard. It's really hard. I'm not very good at it, and it's kind of limiting. Well, maybe not limiting, but for me it is, because I don't know how to take full advantage of it, I suppose, is the right way to think about that. But I'm much more comfortable in C++. So I've finally managed to convert everything over to C++. And all it took me doing was... Yeah, it's there. I don't know what you're talking about. So this is the kernel. All it took me doing was doing a forward declaration right here of the kernel function wrapped in an extern C. So anytime you want to call a function from assembly, you have to make sure it's either, well, a regular old C function can be called right away from assembly because the symbols are the same. If you, well, here, let me show you the boot file. So here this is boot utils ASM. It's an assembly file. It's the very first thing that gets called. And you'll see down here, it eventually does this call kernel main. So this symbol kernel main has to exist somewhere. And it does. It's right here in, nope, well, where'd it go? In kernel main. So when the compiler goes through and gets all the symbols and compiles everything together, it recognizes that symbol as kernel main, and then the linker looks at those and says kernel main from this assembly. Oh, well, here's kernel main here in this C file. These must be the same thing. So it makes that connection. And C is nice because it keeps symbol names just what you'd expect. The symbol name for kernel main is going to be kernel main. But unfortunately, C++ is not so straightforward. C++ does this thing called name mangling because C++ has this cool feature where you can do what is called function overloading. It's where you can give two functions the same name, but as long as you make them take different parameters, the compiler can still figure out which one is which. So if I did, let me show you. So if I did void function 1, take an int number, and void function 1, take a char character, like so. Even though these two functions have the same name, the fact that they take separate arguments, or different types of parameters, allows the compiler to know which one you're talking about. So if I were to, down in the code here for some reason, it's not implemented yet so it won't work, but if I said function, if I gave it a char equals that, yeah, there we go, like that, and then called function 1, pass it bleh, like that, the compiler would know which one to use because of what I passed into it. And the only way it can actually figure that out is when the linker goes through and figures out all the symbols, the compiler actually assigns extra characters onto the end of the name, so it ends up being unique. So even though to me I see two functions that have function 1 as the name, the compiler might go through and name it function 1 zru blah whatever, something like that, and then the second version of it might become function 1 r2 r3 blah blah blah, something like that. And these extra characters are assigned automatically by the compiler, and there's not really a way to know what they're going to be. So if I wanted to call a function in C++ directly from assembly, let me get rid of this, I would have to know what the compiler is going to assign to the end of the symbol so it can differentiate. And then what I would have to do, if I go back to boot utils here, kernel, when I call kernel main, I would have to know what those extra characters are going to be. So that would be ZR1, ZR3 underscore, I don't know, something like that. And then call it like this. If I could type. And it'd have to be like that. But, unfortunately, there's really no way to know what extra characters the compiler is going to append onto the end of your symbol. And in C++, even if you overload the function or not, it always does this, in case you want to overload the function. So the way around this is this funny little extern C keyword. This tells the compiler to use original C-style symbol making instead of C++. So the fact that I have wrapped this forward declaration in an extern C, it tells the compiler, don't name mangle this, and just leave it as is. So the symbol name stays kernel main. And so that's predictable, and I can call it from in boot utils predictably, and it will always work. Now, when you use extern C, you can't use a lot of C++y features. What up, nerd? Can't hear you right now. That's fine. I don't know what else I would expect. But anyway, so wrapping in the extern C forces it to keep regular C symbol making, but that means while you're inside an extern C scope, you cannot do function overloading, specifically in C++, because then it doesn't work. So I couldn't inside an extern C. Yes, it is. What are you talking about? I just changed the name. This is the same project I've been working on. I just decided to change the name. No sticky keys. But let me show you here. So if I make those function1 take an int, well, I need to make that void. And void function, I cannot type. Char character. I believe it won't let me do that. Yeah, if I were to try to compile this, it would complain. Let me try and make it, see what happens. Oh, it allowed me to do it. I guess maybe because I didn't implement it. But if I tried to call one, I didn't try to call any of them, so it might have still allowed it to build. But if I tried to call them, it would be confused because it wouldn't know which one to use. Because they're inside this extern C scope, it left their names to be exactly function1. So again, it's limiting. But so you only want to wrap the things that you're going to call from assembly in the extern C. So this kernel main function is called from assembly, so I just wanted to make sure to wrap just this in extern C. There's some other functions too, like if I go to... Where is ISR helper, I think? No, it's descriptor tables. Yeah, see, so this function right here, or this file, it's called descriptor tables, and these two functions right here, gdt flush and idt load, are both called from assembly. Actually, where are they? Right here. See, there's two individual files for them over here, gdt and idt. See, here it is right here. So this is the name of the function, gdt flush. So I'm telling... Man, my editor's not working with me right now. I'm telling the program here that there's a function out there called gdt flush, and don't mangle this name whenever you see it, because it's got to be called from assembly. All that to say, I had to do that just so I could make everything be in C++ now. Everything internal to just C++ or CPP files can all call each other, because they'll all be linked in the same way. But if it goes to an assembly file external, it's got to have the extern C, so the name doesn't get messed up. So, all that being said, what I want to do is start making use of some of C++'s features, which is specifically the ability to create classes and objects, because to me, classes make so much more sense, and it's much easier to encapsulate things. So the way I've got things kind of set up right now, if we look at the kernel, it goes through and just does some stuff one at a time, where it's just setting up a bunch of memory locations and doing a bunch of actions that are relevant to this particular thing. So what I would like to do is encapsulate these into classes so I can treat them more like individual object devices and use their methods to do stuff. So for example, pick install. Pick stands for Programmable Interrupt Controller. That's a physical device on the motherboard, and you have to send some data to it to set it up correctly to allow things like the keyboard to be sensed. So what I would like to do is create a PIC class, because it can be represented pretty well by an object because it's a physical thing, and then give it a member function called pick install and call that instead. And the same thing like for the keyboard, create a keyboard object and be able to call keyboard install and have the keyboard contain all the variables and stuff that it needs to keep track of. And the timer, this is the time install, this starts the system clock ticker. The timer is kind of a device in its own, so it'd be really cool to make it a specific class all on its own. Oops. Sorry. Okay. So, and the VGA controller that I've been griping about all this time, it'd be really nice to make it a class all on its own and maybe redo it from scratch. Maybe this is a good excuse to redo it from scratch right now. So Yeah, let's try that. So here's VGA controller. It's not that pretty because it was like one of the first things that I implemented right after getting the stupid thing to boot without crashing, just so I could display "Hello World" and prove that the thing works. Yeah, so it's got some functions here, like there's a clear screen function that just goes through the entire video memory and puts a space. There's a big color enumeration that I can use to switch the text color. It keeps track of the cursor X and Y. So these are things that would be great to make member variables of a VGA driver class. So it can keep track of it on its own. It can keep track of what color it's currently printing characters at. So that would be nice. There's also some stuff here that updates the cursor. The cursor is that little blinky thing on the screen. I'll show you. See the little blinky thing right here? This is the cursor. It doesn't move on its own. So if you start typing or spitting text out onto the screen, the cursor will just stay there as is. So you have to manually move the cursor, and that's what I'm doing every time I type a character. It's actually moving the cursor specifically to the next slot, because that doesn't happen on its own. And so there's a function to do that. So that would be something that could be contained. Yeah. So let's try that. So I don't want to completely wreck this file because it works. I don't want to break stuff that is already known to work. How's Hannah doing, Zach? So let's make a class, VGA driver. Okay. And I think I might want to make these singleton classes because there's not really a reason to be able to have more than one. Yeah, that'll work. So we'll do public, private. So private variables, stuff would be really nice. And again, I'm not a fan of using these uint stuff. This is back when I was still learning, pretty early on. But I don't think I really need to use these. I think I can probably just be fine using standard. Yeah, because look at this. A size T data type is a long. A long is 64 bits, and a long I think is double that. So completely unnecessary. Let's turn the music up a little bit. There we go. Yeah, so I don't think we need a long just to hold these two constants. These two constants right here, VGA width and height, are defining how long and how tall our text area is. Because VGA text mode is 80 columns wide by 25 rows tall. Yeah, so those should go as...
Okay, now I got my filthy dubstep banger. But no one thinks out at my show.
Those should stay inside there. And then as a naming convention, I would like to start following is to append or prefix everything that's a member variable within. I'll try that out and see what I think about it. Yeah, and I'm not going to make these size T's. We're going to make these ints. Actually, these could be chars. to conserve on data, because a char can hold up to 256. Yeah, so let's add some comments. Find the size of the text area. And then we'll do same thing for the cursors down here. I'll just steal these. We'll make these chars. Char. Oh, we'll do unsigned char too, because these can never be negative. You know what? Unsigned. Yeah, these values can never be negative, so the location of the cursor. So the text colors are also held in 8 bits. That's what this enum up here is for. So we can make those member variables too, what our current colors are. Oh, right, I was going to try and do this. So, yeah, unsigned char text color. Oh, I don't need to define these right now. Consts have to be defined when you declare them, because the definition of a const is that you cannot change it after it's been instantiated, so you have to provide it with a value. But these guys right here, these guys will just get called in their constructors. Color. Yeah. Okay, we shouldn't need these anymore. So this here, this is where the magic happens here. So the screen is what's called a memory map device. And basically all that means is there's a specifically set aside location in memory that if you just write data to it, it will immediately be acted upon. So the screen data, the screen memory I should say, starts at this location right here, B8000 in memory. And so if you just begin writing bytes into that spot, they'll start showing up on the screen. So yeah, so that's the starting location. And then you remember how our width and height were set up here? So starting from this location, the next 80 bytes will be the first row of the screen location. And then the next 80 bytes after that will be the second row. So we have 80 bytes times 25 rows of screen data. So what's 80 times 25? 80 times 25. 2,000 characters. So the next 2 kilobytes after this location are just the screen member, the screen data. Yeah. So we have 2,000 characters. Wait, is that right? Did I type that right? That seems like a lot. 80 times 25. Yeah. Excuse me. Yeah, so let's... How are we going to do that there? I guess we'll just do a unsigned... We'll set it up in the constructor. It's a 16, so that's a short. Shorts are 16 bits long. Chars are 8 bits long. Ints are 32 bits long, and longs are 64 bits long. So we'll call this screen buffer. It's a pointer too, so we'll do it's going to hold an address. Yeah, so this means it's going to hold the address of some place, and whatever that place is, treat it as an unsigned short of 16 bits. So the location of screen memory. I don't really want to. I don't think I want to define that as a const because I don't know if pointers like that. Is that all the? That's all the variables. Okay, so I want to set a... I need to make a public constructor, VGA driver, and ceremonial destructor. Don't really know if I'll need it right now, but can always implement them later. Actually, I want to make these singleton objects. So, in a singleton object, the constructor has to be private. So in a normal class, you can just make as many copies of these as you want to, and they'll all be separate from each other. But a singleton object is special to where there can only be one instance of it. And something you have to do is make the constructor private, so nobody can call it. Like so. Gotta approve the rules to be in my own chat. He says he can't hear me right now because he's on my phone. Okay. I'm a bit fuzzy on how you do singleton class, so let me... Singleton in C++. Let me just look up the... Yeah, so you make the destructor public, so if and when you're eventually done with it, you can destroy it. Anybody can. And then you make a... Let's see, has this here. Yeah, static. So VGA driver. You make a pointer. Get instance. Yeah, so when you call this function, it will return a pointer to the only instance of your class. And you can give that pointer to as many places as you want, and they will all be referencing the same object. And then inside your private section, you want to actually give yourself the static the actual instance. So this this member right here will hold the address of itself. And then the get instance function will distribute that address to whoever asks for it. And so everybody who has that address will be referencing the same object, which is this one version. I think. Is that right? Doing some reading here. Now that I think about it, this might require dynamic memory allocation, which I don't have yet. Because the way singletons normally work is at runtime, the first time it gets called, that's when the pointer gets filled up and the instance actually gets created. And so anything that happens at runtime requires allocation. So this might not actually work to make it singleton. I might have to just declare it statically. I'll go ahead and do that for right now. I mean, it's not wrong. You could just create more than one VGA driver if you wanted to, which there's not really a reason to. Did you send her a photo or something? You wax your beard? Or the rest of those peeps who wanted to get my stats up. Okay, so this is all the data we need. And then now we gotta make some functions. So most of these functions down here will probably just move into becoming member functions. Like the set text colors. Actually, this is all supposed to be, this should all be defined in a VGA H file. What am I doing? I should put this in a H file. We'll call it VGA controller class. So all this stuff, including this enum, should go into VGA controller class. Def VGA controller class .h define VGA class. I know there's a typo. Okay. So now we'll put all these definitions in here. Yeah. So some functions we'll want to make public so they can be controlled from the outside. So like the set colors is probably one that could be public, because we want the kernel to be able to say, okay, VGA controller, I want you to use these colors, and just go for it, and it says okay. So void set. You know what? I'm gonna type def this. So that way I can say char, no, VGA color text, VGA color background. See? So what a type def does, it basically lets you create a new type of variable. And so now I can actually pass in these actual names. And making it a type def forces me to only allow these types of values to go in there. So I can't create a VGA controller or a VGA color and pass it 16, because 16 is not defined here. It can only be 1 through 15 or one of these names. Yeah. So void set color, and then I want to do void put print char, I believe was one. Char, unsigned char. Because before, remember, I had that issue where right now print char takes a unsigned, a signed char, and I don't think it needs to. So I will do unsigned char. So we'll try and see if we can implement it as an unsigned. Because like I said before, char characters do not... If I want to use 8 bits to represent a physical character, like an ASCII character, none of those use the negative sign. So why allow it to maybe contain a negative sign accidentally? There's like a car alarm going off somewhere outside. So these are the these are the things that we want to be controlled from external. So we want the kernel to be able to say, hey, VGA controller or VGA driver, print this character out for me, will ya? And pass it the character, and it'll be able to do that using this function, or set the colors quite nicely. Okay, so that's quite nice. And then a lot of these other functions in here will just be private functions that are internal, like the cursor, the function that moves the cursor along with you. We don't want anyone to have to tell the VGA driver to do that. We just want the VGA driver to do that. So that will be an internal function only. Yeah, so you have to do some stuff here to enable the cursor first. This is using some of those port commands. You have to write a specific bit of data to a specific location. And I like making these enums. So I need to go find out what those are actually named and create an enum for them. Text mode cursor, here we go. Huh, so these are just... So here's the OS dev page about the cursor. Again, I implemented this a while ago, so I don't really remember exactly what it's doing. Oh, it looks like it looks like I just used this. Yeah, this was copy and pasty, and I don't like that, so I'm gonna try and reason my way through it so I can make it not copy and pasty, so I can understand exactly what it's doing. Yeah, like I said, this is like my first implementation of anything besides a booting kernel function or a booting main function, so I was still learning a lot at this point. So enabling the cursor allows you to set the start and on the screen, the character and the color data. So you can vary the color from one character to the next if you want to for any reason. So that's a good one to keep. So we'll go and keep that one. These are all. Oh, is this one return something? Yeah, this one. Yeah, see, this one returns a short or a 16-bit number, which contains 8 bits of character data and 8 bits of color data along with it. So that's a good one to keep. Unsigned short format char data. What did it take in? Just a character. Okay. C. Should be fine. And like I said before, see, some of these use regular sign chars. I'm going to try to go through, when I'm refactoring this, I'm going to try and go through and make it to where they use unsigned chars, because when dealing with characters, there's no, like, when dealing with printing physical characters, there's no need to use a negative sign, because none of them, no ASCII number uses a negative value.
Everybody crazy?
And so by making them unsigned, that protects you. If in any case you accidentally try to shove a negative number into it, it'll cry foul, and so you can't do that. It's good to try and do little, think ahead on little things like this that'll help you in the long run, or protect you later on. Internal functions. Okay. Let's keep looking down here. So this place char at location function, it takes in what character you want to print, and where you want to put it.
Crazy?
Simple enough. So anywhere in that 80 by 25 grid, you can place any one character in any location. So this is a good one to keep. We'll take this one. I mean, most of these functions are pretty necessary, I'd say. So it's good to go, and they're all going to come in. But see, like, these don't need to be size t's, which are long longs to hold a maximum of the x. That's, I believe that's the 80 columns wide. We don't need a long to hold up to the number 80. We can store that in the char. Let's see, all these can be unsigned chars.
Everybody crazy.
Okay, so let's keep moving forward. The scroll screen function here, this is what will move the entire screen up and clear the bottom line if you get to the end at the very bottom of memory. So if you get to the location, you know, 8025, which is the bottom corner of the printable area, and you want to print another character, this function will jump in and move everything up one line and start over at the beginning of the next line. So you lose the function, or sorry, you lose the data at the very top row. It gets erased. It gets pushed out. For right now, anyway. But it makes it so you can type things like the Enter key to move you down. And it keeps the screen moving, so you don't just print off the bottom of the screen and can't see anything. It keeps the bottom of the screen visible to you all the time. So that's a one we'll need. That's good. The print char character. This is a big overarching one. So this one is keeping track of where our current location is, and so if you feed a character into this, it will just pop it at the next available location. So this is a high-level one. That's the one, yeah, that's this one right here that I made public. So this is the one that'll be callable by other things to say, hey, I want to print a character. Just print this character for me. And the VGA driver says, okay, and takes it and does its thing. So we've already got that one up here. The clear screen, I think that's one we'll want to make public, because we do that at the very beginning. This is in the kernel. The first thing we do here is clear the screen. So we want to say, we want to tell this VGA driver to clear the screen, or clear the screen. So that one can be public. And then these functions right here, they were kind of just helper. I don't think they need to exist though. I just had it automatically pop in some values, but we've got the set color function, so I don't think these really need to exist. They can just go away. Okay. Okay, and I think that is it. Okay. So now, top of this file, we need to include that file. Include VGA controller class. So I think, if I can remember how you do this, VGA driver. Yeah. See, so now we can implement the functions in the CPP file. Just like you would for any other class. Okay, and I gave these all the im in the front. Text colors, is that not what it is? Oh, color. Background color. Like that. Yeah. Set color? Is that what I called it? No, I call it set colors. Oh. That's because I made this new text, and this is called background. Background. There we go. Like so. So now you can just pass in some VGA colors, and it will set it for you. Enable cursor. I think these were signed char. Signed char. Right? Oh wait. Did I really use... Oh, this does take some values, doesn't it? Okay. What were they a minute ago? Uint, yeah, so unsigned. They were unsigned characters. Nope. That's not what I want. Unsigned. Yeah, so unsigned char is fine. Unsigned char is fine. Let's go give these to the cursor start. There we go. So now let's replace these hex values, these ugly hex values, with that pretty enumeration we made a minute ago. So that's cursor lower and cursor upper. Hey, thanks for the follow. Your destiny. Alright, so yes, that's cursor upper. Oh, I feel so special. Okay. Okay, so like that. So that should be fine. The update cursor. These can, I think I'd change these to be chars. What did I do? Yes, unsigned char. So let's make these. Change these to cast unsigned chars. Then this is cursor lower. This is cursor upper. I think I made this in member variables. That's got to be an M. Yep. Signed short. Okay. Yeah, I'm replacing all these uint whatevers with more readable names. I'm not a huge fan of these. But again, I was learning first when I was doing this one, and that's what everyone online was doing, so I just kind of did it. But I don't really like them, so I think I'll just replace them with yeah, see, because all it's doing is it's type defing. If you read the tooltip there, it says a type def and unsigned short is this uint16, so it's just replaced the word unsigned short with this, so it's exactly the same thing. So format char data, unsigned short. I think I made this unsigned. GA driver. M. So this is the one that takes your text data, the character that you gave it, and it concatenates it with the current color data to form a 16 bits VGA entry with your text and your color, and then puts that in a location in the screen memory, and the screen will render it. Yeah, so it looks like the color based on this here. It looks like the color is the first 4 bits, or the background color is the first 4 bits, then the text color, and then the actual character is the lower 8 bits. Yeah, so 4 bits of background color, 4 bits of text color, 8 bits of character. All that makes 16 bits, and that gets placed in VGA memory. So, unsigned char, unsigned short, unsigned short, unsigned short. Yeah. Yeah, blends the char with the color bits that are needed for VGA. So that's good. And so this guy right here, here's that place char at location. So it actually calls the format char data to get the full 16 bits to place at a location in memory, specified by the X and Y that you have picked. So that's unsigned. I think we change these to unsigned chars also. This will greatly simplify. And then once I'm done with this, I'm actually going to go through some of these and rework the algorithm that it's using as well, because there's a couple of bugs, as we've noticed before. So here's that screen buffer. That's that location in memory, that B8000. That's the physical location in memory where screen data starts. And so what we can do, we can, starting at that location and then multiplying by our X location, can let us move in 16-bit chunks across that, starting from that memory, and we can start placing characters in there, and that's how they'll show up on the screen. So say if I were to pass in an X of 2 and a Y of 2, for example, we would, let's see, so we would do 2 times the VGA width, which is 80 characters. That would move us, so we would do 2 times 80, so we would go 80, 80, plus the extra 2, which would go 1, 2, so that would put us at the location of 2, 2. It's linear in memory, so every 80 bytes, or every 80... They're 16-bit entries, so every 80 shorts is 1 row, and then the next row begins right after that, so we move 160 shorts over from the start, plus the 2 extra, and that will make it seem as if we are going 2, 2, and it'll be plant that character right at that location. We'll try and get it working, and you can see. It's kind of tough to explain. And like this function right here, this is really, really crude. I would like to use memcopy to do it, but that wasn't working right away, so it just uses a nasty for loop to kind of go through and move everything back. That's how it moves everything up 1 row, is it goes through and moves every entry exactly 80 units backwards, because 80 units is 1 row, and so if you move a short 80 units back, it will move up to the next row, because that's backwards one row. Just gotta fix all the names. Change all the names. I'll go through and get all the naming right and make sure we can treat this as a class like I want to. And then if that works, then I'll go back and rework the printing and scrolling logic inside. That's an int. Oh. Yeah, so this first for loop here, this is what goes back and moves every character in memory backwards 80 to make it move up the screen. And then this other for loop here is what goes down the bottom row and wipes it out with spaces to clear it. Yeah, see, it does the print char at location, a space, and these are the coordinates for the bottom row across. I made that unsigned. M. So this is the print char function that's exposed to everything to use, and this is where a lot of the real logic happens. So this is something that I need to go back and totally redo. But basically what it does, you feed it the char, the character you want to print, and it decides what to do. So, like, the first thing that it does is it checks to see if the char is a new line, which is what happens when you hit enter. And if it's a new line, then it actually will just move your cursor location down. It doesn't print anything because the enter key isn't supposed to print anything, but it's supposed to do something. So it just updates our cursor location. And it also checks if our cursor location is already at the bottom, then it scrolls the screen. Like we were talking before, it moves everything up and clears out the bottom row because you can't go any lower without going off the screen. Yeah, so this here needs to be... Get rid of that comment. This needs to be reworked. Yeah. And this final one, this is the clear screen function. It literally just goes through every spot in memory, prints a space, and then when it's done, puts the cursor back at 0, 0 at the top, like it's ready to print again. And I just realized we need to implement a constructor. VGA driver. VGA driver. So what we want to do is we just want to zero out a lot of this junk. So we'll set the mouse cursor X and Y to be 0 to start. We can set the text to be something default. The colors, these can be something default. So let's get them back there. What do you want to set to? So let's do equals VGA color red. That'll be our text color, and the background color will be VGA black. Like that. To start with. So that will zero those out. Or define them to start with, I suppose. The screen buffer memory, we gotta set that up. Equals... How was I doing that before? I think I did... Send short pointer to OXB8. Gosh. 0, 0, 0. I think that's what it was. So this will set that screen buffer location to be the very beginning of video memory. And then starting from there, we can just go in 16-bit increments to get the individual characters. Right, okay. So I think these are defined already. I think that's everything. I really wonder if this will work. So now, to use this, in the kernel, we don't have these set text color functions anymore, so those will have to go away. Those have to come out of standard lib or syslib, I believe. I don't think we actually need any of those anymore. I wonder how this is gonna work with oops. Oh wait. Needing extern stuff. Actually, I don't think I'll need to do that anymore, though, because I wanted to keep these functions in a central location, which was syslib. But now that these are defined in their own H file, all I need to do is just include the H file into kernel, and it should be fine. So I don't think I actually need that anymore. And I think in standard I/O, where I have, oops, that's keyboard. Standard I/O, here we go. See, print char is in here. I don't think it needs to be in here anymore either. Yeah, so now oh, print. Oh, we're gonna have to rework printf too, though, because printf was. Okay, let's take out printf here for a little bit. Oh, printf isn't gonna work anywhere, is it? Because printf. Let's go look at it. Printf is using printchar, so now it's gonna have to get. It's going to have to do VGA driver .printchar, and it's going to have to know the instance of the VGA driver. That's why I wanted to do a singleton object, so everybody everywhere would be guaranteed to be using the same instance of the VGA driver. So I'm going to have to rethink this. I could give VGA driver an implementation of printf. I'm glad you agree. That might be the way to go, but then no other file could use printf unless it knows about the VGA driver. Man, I really need this. This is where I need to get into the concept of standard I/O. So ideally, what I'd be able to do is in. Oh, clear screen's not a thing anymore either. What I would do is, well, let me just show you. So all we got to do is include that. VGA controller class now, and make an instance of it. Okay. Driver, VGA controller. Wait. Yeah, so now what we get to do, VGA controller dot clear the screen. Right? Like that. And then we do VGA controller set colors. VGA color, well, it's already going to be zeroed out to red, so we don't actually have to do this. But if we wanted to change the colors, we could just feed in a new color right here. You know what I'm going to do? I'm going to comment out the entire kernel for right now. And just see if this works. It's not going to do anything other than this. So what we should be able to do is VGA controller dot print char, a single char, an H. I have no idea this will build. Constant sign char, really? Oh, is this defined to be a regular char? Darn it, maybe it looks like I can't do the unsigned char thing like I wanted. Because it's interpreting this as a char, as an unsigned, or as a regular signed char. So what if I do const unsigned char? Like that. Unsigned char pointer. Okay, that's really clunky, so I guess I can't do the unsigned char thing like I wanted to. I have no idea this is gonna work. Oh, nope. That's not what I wanted. Yeah, so it's complaining about, it's still trying to build all those other... I believe that is a false statement. The char is demand representation. Char is short for character, FYI. It's the smallest... Okay, it's the second smallest data type. There are booleans, which can either be true or false. So those are 1-bit. Chars stands for character, which can be 8 bits, so that can hold a number of up to 255. A short is double that, 16 bits, which is 2 to the... Where's my scientific? 2 raised to the 16. So a short can hold that as its maximum number. And then an int stands for integer, right? That stands for integer, which is 32 bits. So that's like 13 million something, so 2 to the 32. Oh, I was wrong. Oh, wow. 4 billion. So that's the maximum number. You gotta get to the next and the next. You got 1, you got 4 more. That's math. And then there's what's called a long, which is 64 bits, which is some freaking huge number. You're gonna quote it right. Gosh. 64 raised. Nope. It's 2 raised to the 64. So a long can hold that as its maximum number, which is huge. And so the difference between signed and unsigned, so if I do that, if I just say that creates a signed char. So it can be actually negative, and the final bit is used to say whether or not it's negative. So it's got 7 bits of data plus 1 bit on the end to denote whether or not it's negative. So a char a regular assigned char can be negative 128 to 128. And an unsigned char, like that, can be from 0 to 256. So for whatever reason, it's saying that if I just type out a character, see how it says char? That means it's interpreting it as a signed char. And so if I want to use it the way I made it, I have to put this in front of it, which is really, really cumbersome, and I don't want to do that. So I guess I'll just have to make it use regular signed chars and whatever. I'm never wrong about these things, you know. Okay, so what do I want to do about this? Alright, how about instead I switch gears and work on something that might be a little more interesting. I'll come back to this later. How about something you guys can interact with? Where's a recent? How about a Twitch chatbot, guys? Yeah. You guys want to try this? Try telling it. Try typing exclamation point you pretty into the chat. Isn't that neat? It's only got 2 commands for right now. It's got the you pretty command, and then this one right here. Both very pretty. You're a lovely wife. You're very pretty. We can make it say other stuff too. Let me show you. So if I just add another check here, so this portion right here is reading your message. So it figures out it gets your username. See this, let's see, where is it? See this right here? This is the actual message that comes in. And it's got your username included and the message that is part of it. So it figures out what your username is and gets your message out of it, and then creates a new message and pops your username in to say your name. So whoever sent the message, it'll pop their username back in and send out the message again. So we can say something else, and we can make it say other stuff too. So if, I don't know, like There we go. Is it? If this right here, so we'll say if exclamation math is in message, we will send to chat f big yikes. Yeah, you could have it do calculations. We can try that here in a second, actually. Here, let me kill it. Here, I gotta start it. Here, hold on. There it is. Try it. It's gotta be lowercase. It doesn't do caps. There's a way you could get around that probably. I could make it to where it always assumes everything in lowercase. See? Big yikes. It only needs one. the first time it finds the first time it finds this exact string, it'll do it. So the first one of these it finds in the message, it'll react to. So if like you suck math, see it picks the. Oh wait, did it actually do it? Oh, interesting. So it can find, that's interesting. So it can find them in this order. See, because I did the you suck first, it got through that one. And then it also found, and then the next portion of the message had the math in it, so it was able to do that one. You guys. Know your destiny. You're pretty. You pretty. I wonder if I can get it to do some math here. So let me take this one. So number equals. So we got to parse the message out. So let's make it say add. Let's make it add. See if I can make it add two numbers together. So let me do for num in line. No. I want split. Where's this? Message dot split. That's what I want. On a, let's do a colon. Number equals 0 for num in let's see, inputs equals message dot split for num in inputs number plus equals num. Maybe this will work. Send to chat. So send to chat. So pop the username in. Your sum is number. I have no idea if that'll work or not. So the idea here is you can put in a set of numbers separated by colons, and it will add them all together and give you the result. No idea if this will work or not. Let's break that. You got to do math first. So like, if I have no idea this will work. So math 1, 2, 2. Nope, it failed. It broke. Oh. Stir. Got it. That's what it is. So when it pulls things out of the message, it's a string that's like text characters, and to do math on it, it has to think about it as a number actually. So I have to tell it to convert this to an int. Invalid syntax. Why? Unsupport operand types for plus equals int and string. Really? Why not? Do I have to do this? Okay, that built. And you broke it. Invalid. Oh, put a space between your numbers. But between math and the numbers. Nope, nope, you're breaking it. There you go. Is that wrong? Invalid literal for int with base 10. Huh. Where's it breaking here? File. Yeah, that's the idea. It's not running right now, so it won't. I have to start it. See, it says I've arrived. That's him saying I'm here. Same quit season means of production. Oh, I have an idea. Let me do... new message equals message dot split at a space, and then new message. List has no... Oh, inputs 1. There we go. Hold on. There we go. What? Here, try it. Yep, broke. List object has no attribute split. Oh, my bad. Wrong spot. That's the list object right there. Got it. Never mind. All right, try it. There you go. Try stringing more numbers. It should get them all. I believe that's correct. And the other one should still work too. Here, I'm actually going to make another else. Yeah, so it's still... Oh, here, I can fix that actually. Here, let me do... to make it to where it doesn't chain them around. I think if I do else if here, send... Hey, Nate. We're playing with my chat bot. Unsupported. Oh, ha. Here we go. User, you fool. Unsupported command. Alright, killed it. Oh, is it elif? My bad. There it is, yeah. What? Send, oh, whoops. Oh, wait, dang it, no, that won't work. Because then it'll say that for everything that you guys say. Never mind, we'll get rid of that for right now. There you go, try it. Nate, try typing any one of these three things. Well, try typing. Well, here, let me show you. You can send a command like. There you go. See, you caught on. But you can also send, yeah, exclamation marks before commands. But you can also send like this, and it will give you the. Well, you got to pass numbers into it separated by colons, and it will add them for you. What do you mean only works in order, Sam? Colons, Nate, not commas. Yeah, I just fixed that. I just fixed that. So it'll only do one. It'll only do the first one that it finds now. They won't chain together like that. I just fixed that. Did it just break that? Oh, we died. It died. That's why. Something just happened. Oh, it's because Nate, it's because you sent, look right here. Right here. This is what your command was, Nate, right here. You didn't send any numbers with it, so it freaked out. It tried to find the numbers that were associated with it, and there weren't any, so you broke it. Well, here, I can fix that. Let's see, split 0. How do I know if there's a 0 in a list? Because it tries to split everything that has a colon in between it. It tries to split those into individual things, and then if I can check to see if that's a 0 amount, then that means it didn't work, and it can say something like, "Hey, you need to pass commands." You just broke it with a freaking decimal, Zach. I wonder if I can. Yeah, you did. See, look right here. It says it tried to interpret a decimal as an integer. You sent it right here, 5.4. It's not running right now, Nate. Nate, don't. Oh, that's a good idea. Can it try negatives? Here, let me run it again. Try that again, Nate. Try negative. No. Zach killed it with his decimal place, but try a negative number. That's an integer. Cool. It works with negative. It works with But what if I make it interpret everything as a float? A float. New lesson. A float can hold a decimal, and decimals can be held in floats. They just have decimals of 0. So here, let me start it again. Try decimal again and see what happens. There you go. Well, here, just to make it more correct too, let me change the colon to a plus sign. So now separate your numbers with a plus sign, and then it'll make it say like all these numbers plus, and then it'll pop you out your sum. Someone broke it. What did you do? Oh, I got rid of the colon. Nate, I just told you I switched it from colons. No, math square root is not going to work. Don't say that. There you go, see? And it can just do it. I'm going to look and see how to tell how a list is 0. Python 0 list. How to tell if Python list is empty. There we go. So I can have it catch if you send if you send the math command with no parameters. Oh, if not A. That's pretty awesome. Here, so watch this. So if split plus, so if not inputs, send to chat user. Oh, that's the I need F. So I'll put the username. So user, you fool. Math needs inputs. Oops. Else, do all this crap that we did before. So now it should catch if you don't send any inputs with the math command, it should stop you. What? Way to go, Sam. You broke it. Inputs. New message. Oh, my bad. I checked the wrong thing, so we should be doing new message instead. Else, this should go down here. Hold on. Oh, Nate, that's oh, come on. Index list out of range, huh? Sam, you broke it again. If not, new message. Let me print new message to the console here. Just send math. Yeah, so it sent just split. So it only found one. Oh. So it's still finding at least one. See this right here? So this was the contents of your command after it tried to split. There's no sarcasm command yet, guys. I don't know. Why? Check this. I guess I could check the size of the string. Or the size of the list. Python C size of list. Get the length of a list. To find the length of a Python list. Well, see, so if you send the math command with no numbers, then when it tries to split up your command to get the stuff out, it comes out with 1. So if your command only has one thing in it, and then that can assume that there wasn't any parameters, and it can say, hey, you suck. There we go. So we'll try len. If len new message equals 1. Nope. Object type. Object of type bool has no. Oh, pfft. I'm a goofball. Equals 1. I put it in the wrong spot. There you go. Try it. Try it. There you go. Now try it correctly and make sure it still works. There you go. I'm just gonna buy an entire array of clothes. Well, yeah, that's because it's trying to print it out as a float that has a decimal, and so it's always adding 0.0 if there's no decimal place. You need a comma after the username for what? All right, so what should I? What should the sarcasm command do? Wait, what? That's gonna break it, Nate. Oh, we died. What did someone do? Oh, look what you did. Nate, look what you did here. Oh, no, Sam. You sent this message right here. So it had the exclamation math inside it. And so it interpreted that as the math command. And then it freaked out. So I guess we should make it check. Yeah, exactly. That's what it was. So it found the math command in your message and then freaked out because the next. Well, if you do the math command by itself, there was something after it, see? And I think it tried to actually use that. Well, here, try it. I believe it'll work. Try it. Do something, you suck. See? So I guess we could check to see if the command is the first thing. Yeah, see, you broke it. It's trying to use. Yeah, that's borking it up real good. Oh, I know what we'll say here. Send to chat. Chat f user is not impressed. Try the sarcasm one. You spelled it wrong. Is not impressed. Oh, I wonder if we can make it pick up a username. That'd be really cool. If you use like the @ sign. So you could say sarcasm to someone else, and then it could say user is not impressed with person you're. I wonder how. Yeah, something like that. All right, buddy. Good night. Thanks for coming. Wonder if there's a way I can get a username out of it or have it. It still works. Nate, stop freaking breaking it. Nate, you keep breaking it. What did you expect with that? Of course it's gonna break. You broke it. Okay, I wonder. See if I can use an @ sign to get like a username out, or someone else, or another. I guess I wonder if there's a. All right. Good night. Yeah, I've been at this for a couple of hours now too, so. No, about you pretty. No. No, you pretty. Well, see, the you suck command doesn't take in any other argument, so it just looks for the exclamation marked word, so it doesn't break if you add other stuff. And you can see the output down here too in the console. It's printing out the same thing. Well, that's essentially what it's doing. It is kind of it is. Oh, I guess we could say. Oh yeah, here. So we could do like elif. Parrot in message. Send to chat. The chat. Message. Try that. Do parrot and then anything after that, and it should mimic the entire thing. See? And it should work if you have parrot anywhere. Yeah, it just... Well, it finds the first... Well, I mean... No, oh, no, I see what you're saying. No. No, I've got it protected against that. It doesn't look... It doesn't listen to any message that it sends. So if you had... If you had the bot send something with an exclamation point in front of it, then it would just start bouncing back and forth. No, why would I do that? That would freak it out. that would probably mess up the chat, actually, because the chat can only actually take so many messages to it so quickly. No, not for science. I'm not going to do it for science. Actually, here. That's how I feel. And see, it picks up every message you send. See down here? Every message you send, it... Yeah, see? It even does the UTF-8 characters. Wait, what? Look at Bible Thump. What is that? It mimicked it, but it came out to be that emoji. That's weird. Is it really? Bible Thump? That's the name of the emoji? Creeper. So, that's funny. Oh, here we go. Oh, here we go. Let's see. Hashtag, uh-oh, in message. Send to chat. What is that? SSS. Uh-oh. Yeah. You having fun yet? Lost my music. I could, if you wanted to get really fancy, you could have it parse through first and find everything that's got an exclamation point in front of it first, and separate them all, and then run each command individually. Factorials? You can already do that with the math command. You can already do... You can already do that. That's factorial. That's adding factorially, though. Oh, is that... Or am I thinking of summation? I must be thinking of summation. Okay, I mean, it'd be exactly the same as this one. Except instead it would... Oh. we'll call it back, and then use multiplication. You could, I suppose, but that'd be a little tougher. Times equals. This is factorial. Actually, no, you only need one number. I'm sure there is. But I'm too lazy to look for it. So like, moo message. Let me think here. So message splits at a space, and you only need one number input. Oh, you'd have to do like a loop to do it. Yeah, I can take only one number. You have anything important going on later, Nate? Tomorrow? Really? Just straight up factorial? Number equals factorial. New message 2, I think? Or 1, maybe? So, fac 4? Nope. Factorial is not defined. Do I need to include something? Is that what yeah, fac. Do I need to import something? Math, maybe? Oh. From math, import factorial. Try that. Broke it. Integer. Oh. I gotta feed. Same problem. It parsed it out as a string, but I gotta feed it into factorial as an int. Well, I think it matters, actually. It recognized it just now, but it complained about the input that I gave it. So, try again. Is that right? Holy crap, Nate! This is why we can't have nice things. Because you keep breaking stuff. That didn't work. I mean, it's still... Oh. I'm gonna kill that right there. I think you froze it. Well, I killed... Well, Nate, what do you expect when you wanted to cap? When you wanted to calculate factorial of 99 million. Why did you have your computer calculate prime numbers? Okay, fine, whatever. Find narcissistic numbers. Sure, I'm sure. Oh, I see. All right, well, I think we can go ahead and get off. Like cubed and hypercubed. It's right. I agree. But anyway, all right. I'm going to kill it. Talk to you later, okay?